Today's video is about something called similar figures, staying in our unit about proportions. And in order to start off talking about similar figures, we've got to review a concept from last year, which is sides and angles. So anytime you have a shape, it is made up of sides and angles. The sides are obviously any of the lines, or line segments, that make up the shape. And the angles are the distance between one side and the other. So here would be an angle, here would be another, here would be another angle up top, this would be an angle on the side. Those are angles, the lines are sides. So we need to be familiar with that terminology before moving forward. For example, these two triangles are all made up of sides and angles, and the sides are different sizes, and the angles are different sizes as well. For example, we have this angle, which is much bigger than this angle. Okay, and then we have this angle here, which is the biggest of any of the angles up here on the board. Okay, so we just need to be aware of sides and angles. Sides are measured in regular units of distance, like inches or feet, okay, or even miles if the shape is big enough. Angles are always measured in degrees. And you'll see it written, for example, like 150 degrees. Okay? All right. So with that reviewed, let's talk about similar figures. Similar figures are figures that have equal angle measures. And I have the word congruent up here because it means the same as equal. So similar figures have congruent angle measures, but different side measures. Okay? So the lengths of the sides are going to be different between these two shapes, but their angles are going to be exactly the same. So, for example, if this angle is 90 degrees, in order for these two shapes to be similar, then this angle also has to be 90 degrees. Let's say this angle, is 40 degrees. This angle also then has to be 40 degrees. And if this one then is 50, this angle's got to be 50 in order for them to be similar. So the angles all have to be exactly the same, but the side lengths can be totally different. This might be 20, and this side length might only be 8 or something like that. Okay, so the lengths can be different. The angles have to be exactly the same or congruent. Okay, here we have two similar triangles. They're similar because I'm telling you they're similar. And we're going to talk about two more vocab words, corresponding angles and corresponding sides. Okay? So if I tell you these shapes are similar with each other, then we can talk about one side on this triangle corresponding with a side on this triangle. Just means they kind of go together or they match. All right? So for example, side AB on this triangle corresponds with side XY on this triangle. So we could put up here corresponding sides. Side AB corresponds with XY. Okay? We could do that with other sides as well. For example, side AC is going to correspond with side XZ. Corresponding angles are the very same idea. Angle A, right here, is going to correspond with angle X. B corresponds with Y, and C corresponds with Z. So corresponding just means they kind of match. If we're talking about the angles, then corresponding angles are going to be congruent. So angle A and angle X are exactly the same. Sides are not necessarily going to be congruent. AB is bigger than XY, but they're still corresponding because they match each other from this shape to this shape. Okay, finally, we can still have corresponding parts even if the triangles aren't exactly identical looking. Okay, so for example, this triangle has been flipped, but we could still say that these triangles are similar. Okay, and the corresponding angles could be the same. Angle A could correspond with angle L over here. In this case, C is going to correspond with N, and M over here is going to correspond with B. So just because the shapes are flipped doesn't necessarily mean they're not similar. These two shapes could still be similar. All right? Okay, with all that out of the way, how does that actually help us, and what does it have to do with proportions? All right, well, here we have two rectangles up on the board, and I've told you at the top that rectangle ABCD, which is this one, is similar to, this little squiggly line right here means is similar to. So triangle ABCD is similar to, rectangle ABCD is similar to rectangle QRST. So I told you right off the bat, these two shapes are similar with each other. All right? And it looks like I've given you that this side length is 30, and this side length is 8. This side length is 2. This one we don't know. This is what we're trying to figure out. We want to know how long is this side length. Well, in order to figure this out, we're going to be setting up, you guessed it, a proportion. Okay? The best way I can describe how to set up proportions in similar figures is that they've got to be a technical phrase which I like to call matchy-matchy. Okay? They've got to be matchy-matchy. Let me try to explain what I mean. I'm just going to call this triangle, or this rectangle right here, this is going to be the big rectangle, this is the little rectangle. Okay? So here's what I mean. Let's just start with, let's say this side right here. We're going to call this is the left side on the big rectangle, right? Okay, so left, big. And let's say we put that number here, 30. Okay? Well, the number below it and the number directly across from it have to match in exactly one way. Okay, let me show you what I mean. Let's say we put 8 below it. What side is that? That's the bottom side on the big triangle, right? Bottom side, big triangle. I keep saying triangle, I'm sorry, rectangle. Okay, see how this matches in one way? It doesn't match, one's left and one's the bottom side, so that doesn't match, but they're both the big rectangle. So there it matches in one way. Okay, moving over to this side, the number that we put here has got to match this also in one way. So we've got the little shape here. So it doesn't match with big. It has to match in another way. Well, what's the only other way it can match? It's the left side. So left side of the little rectangle. Left matches left. Down here, again, we're going to be talking about the little rectangle, and now that matches little and little. But this has also got to match with the one that's across from it. So here we have the bottom side of the big shape. This has got to be the bottom side of the little shape. So now you see everything matches in one way. Left big, left little. Left big, bottom big. Over here, left little, bottom little. Everything matches in one way from the thing that's above or below it and the thing that's across from it. Okay, now let's start filling in the numbers. Okay, left side of the big shape is 30. So we'll say this is 30. Bottom side of the big shape is 8. So we're going to fill in the number 8. Left side of the little triangle, rectangle, is the question mark. And the bottom of the little shape is 2. So we've got question mark and 2. All right, now we have everything we need. We just have to solve the proportion by cross multiplying. 2 times 30 is 60. And then we've got to do 60 divided by 8. And we have as our final answer 7.5. So the missing side right here is 7.5. This part, again, is all easy. We've done this before, solving proportions. The difficult part is just knowing which numbers go where. Remember, they've got to be matchy-matchy. It's got to match what's above or below it. And it's got to match side to side as well. Let's look at one more example before the end of the video. Okay, here we have two triangles for real this time. And again, I'm just going to go ahead and tell you from the start, these are similar shapes. Triangle ABC is similar with triangle FDE. Okay? I'm also going to have to give you one more piece of information here. I'm going to have to tell you that Smartboard's not cooperating. I'm going to have to tell you that angle A here corresponds with angle F. So A corresponds with F. I'm going to tell you that angle B corresponds with angle E. And then I'm going to tell you that C corresponds with angle D. Okay. Now, it's helpful, I think, on a problem like this to redraw the picture because these triangles are similar, but they don't look the same. This one's like a pyramid, this one's upside down. If it were me, I would draw this separately on a different piece of paper, or through the magic of the smartboard, just go ahead and flip this triangle. Now they do look similar. Okay, and I'll relabel the angles. D, now if you look at it, you got to be careful and make sure you lined it up properly. Okay? See, angle D started here. Where did it end up? It's over here now. Okay, so here's angle D. That means E must have ended up over here, and F that started here ended up at the top. And now there are our new positions of the angles. Okay? So, to go ahead and make this a proportion, let's say that this is side length 5, and this one's 2. We'll say that this is length 15, and we don't know what this is. We've got to solve it through proportions. Okay. Putting in numbers, we'll put this 5 here. Now this is the little triangle left side. So below it we're going to put the little triangle bottom side. It matches because they're both from the little triangle. That means across from this, we had the left side was 5, so we've got to use the left side now of the big triangle, 15. And our last, our variable, the thing we don't know, is going to go on bottom. Okay, finally we cross multiply to solve. 2 times 15 is 30. And 30 divided by 5 is 6. So our missing side is 6. We're going to go over this more tomorrow in class. It may be a difficult concept. You'll have to tell me what you think. But for now, that's as far as we'll go. Don't forget to answer the question in the description, and I'll see you in class tomorrow.